Good afternoon and welcome to the Sensors Daily webinar, Security Fundamentals for IoT Sensors, presented by Alan Grau, Vice President of IoT Embedded Solutions at Sectigo. I'm Matt Dirjish, Editor-in-Chief of Sensors Daily, and I will be your host and moderator for the webinar. Alan Grau has 30 years of experience in telecommunications and the embedded software marketplace. His company, Sectigo, is deemed the world's largest commercial certificate authority and provider of purpose-built automated PKI solutions. Prior to founding Icon Labs, Alan worked at AT&T, Bell Labs, and Motorola. The IoT, a massive entity of connected sensors, is growing dramatically. They are the critical components of systems that are changing medicine, transportation, manufacturing, agriculture, and a plethora of other industries. Obviously, these systems are only as good as the data they collect, and ensuring the integrity of that data starts at the sensor. Hackers no longer view these devices as low-value targets. Therefore, sensors must be protected from cyber attacks. So now you're going to get a chance to sit back and learn from a noted authority about the current security vulnerabilities and threats for sensors and get some security fundamentals. You will also get a practical approach for security in limited resource devices and the role of the gateway in securing sensor networks. Now, before I hand the mic over to Alan, just a few points. There will be a Q&A session at the end of Alan's presentation, but feel free to submit your questions during the presentation and we will get to them in order of their appearance at the end. Also, this webinar is being recorded and will be made available at sensorsdaily.com later this week. Now, without further verbosity, please welcome Alan Grau.
Thanks, Matt. As Matt said, my name is Alan Grau, and I'm the Vice President for IoT and Embedded Solutions at Sectigo. And in this webinar, we're going to be talking about security fundamentals for IoT sensor networks. What are the challenges in securing IoT networks? What are the threats these networks are facing? And how do we go about building security into those networks? So as we get started, the first thing I want to talk about is the security claims that we often see versus the reality in most systems that are deployed. The reality is security is easy to claim, right? A lot of companies are saying that they're providing solutions that have security. Others are saying that, perimeter security really is enough. And in many cases, I've heard a lot of people that I've talked to say, well, my device really isn't that critical or that important or that interesting for hackers. And another one is, oftentimes people are saying, well, I can easily just build in my own security solution. When we actually look at the state of the industry and devices that are being built, what we're seeing is many devices that are being built and deployed with very weak security. In many cases, they're relying on static credentials, username and passwords, or weak symmetric tokens, or other static credentials that can be easily bypassed or stolen. Most of the security solutions, if somebody does roll their own solution, have a very limited point solution. They're not easily managed. They're not integrated into broader solutions. And so we're seeing many IoT devices that are being attacked and compromised. So we really are seeing problems in this space today. One of the reasons that this is an important topic is that building security for IoT devices is a very challenging field. These are very resource limited devices in most cases. You can't just take a Windows-based security solution and drop it into a small sensors-based device. These devices are built using real-time operating systems or some custom embedded OS. And they're also deployed in the field, which creates challenges of its own. They're deployed outside of the security perimeter. They're deployed at a place where a hacker can gain access to the device and exert physical attacks against the device. And they're performing critical functions. We're talking about, in some cases, process control systems in manufacturing and chemical processing. We're talking about, manufacturing control systems, robotic control systems, things that if something goes wrong, we're not talking about just loss of data, but potentially destruction of physical plant, equipment, even injury and loss of life in some cases. One of the other things that's really unique about the IoT world is that many of these devices have a very long life cycle. When we talk about security in the IT world, we're typically talking about devices that have an 18-month to 3 to 5 year lifespan before they're being replaced. So when that device is manufactured, the horizon under which it's going to operate and the attacks that are going to be deployed against it are fairly short term. But if we're talking about, a sensor that's being built into a car, that car could be on the road for 10, 15, even 20 years. So how do we build a device today that can withstand attacks that haven't even been thought of yet, attacks that are going to occur a decade or two from now? One of the other challenges is these devices are not easy to upgrade. Many of them don't have a remote software update capability built into them. Many of them are deployed in locations that are difficult to access. So it's not easy in many cases, or the controls haven't been built in many cases, to do a weekly or monthly update, right? Every Windows PC is getting an update pushed out from Microsoft with security patches and other fixes on at least a monthly basis. And that same sort of infrastructure is difficult to achieve with the vast disparity of devices in the IoT world. So one of the realities is that in some ways, the attacks are similar, right? We're talking about ensuring the integrity of the device. How do we ensure the authentication, the authenticity of the device, or how do we ensure that communication is secure? So the problems at some level are the same, but we have to have solutions that are built specifically for IoT devices. Solutions that can run across a wide range of platforms, both hardware platforms, as well as various software-based platforms, various operating systems, some solutions with no operating system at all. They have to be very scalable, and they do have to be customized to work in an IoT environment and for some of the specialized threats. So on one hand, I know it's a little bit contradictory in that some of the attacks look very similar to IT-based attacks, but others are attacks that are designed more to target a specific IoT device. So all those factors have to be taken into consideration when we look at building a security solution. And as we talk about how you go about doing security, what you end up building into your solution, one of the challenges is, do you buy a solution? Do you build a solution? Do you find an open source solution and integrate it yourself? And all of those have challenges. All the roll your own or pull in an open source solution have challenges. Most of the open source solutions are designed for embedded Linux, and so they don't really scale to IoT devices. And the other challenge is that security is hard. Security is not the same problem that most engineers are used to facing. Most engineers, hardware engineers, software engineers, are very, very skilled and very capable of building a solution to solve a specific set of requirements. And that's only the starting point when you look at building a security solution. Security solutions have to not only meet a specific set of requirements, but also have to consider the unknown. How do attackers go about penetrating a device, go about attacking a device? Well, they're going to use all sorts of techniques that aren't easily captured by typical requirements. So security really is a unique beast in that way, and that you have to be able to think differently. You have to have specialized expertise. Any little mistake in the implementation of a security solution can result in a vulnerability that hackers can discover and exploit. So it does really require specialized expertise. If you have that expertise, implementing it, if you can find and hire that expertise, you can build your own solution, but it's going to take a lot of time and it's going to be very expensive. So in most cases, you're better off finding somebody that can help, finding solutions that have already been built that can be pulled in. So as we look at security for IoT sensor networks, I think it's worth taking a step back and saying, what exactly do we mean? I said earlier that, some of the solutions are specialized. Some of the attacks look like IT attacks, but some are different. But we're really talking about the basic fundamentals of security that you would in any environment. You need to make sure that whoever is accessing the device is allowed to access it, whether that's another user or another device. You also need to make sure that whoever's accessing it has the permission to do what they're attempting to do. So very basic security fundamentals in that regard. Then we have to make sure that the data on the device is protected from being stolen, communication is protected, that you can't disrupt the communication or someone cannot steal the communication to learn what data is being communicated. In the IoT world, we've seen a huge growth in botnet attacks in recent years. There was the Mirai botnet a few years back, and subsequent to that, there have been many variations of that specific botnet. So ensuring that your device isn't vulnerable to be taken over by a botnet is another critical requirement. And then obviously making sure that the device operation can't be interrupted, right? Denial of service attacks have been prevalent in the IoT world, and ensuring your device is protected from that is critical. And the final piece that many solutions have overlooked is understanding how these solutions integrate back in with management systems. It's one thing to be able to know or to be able to protect the device from attack, but that's only a piece of the solution or a point solution. You need to be able to report attacks back to a security management system of some type. And if you think about the way the IT world works, in the IT world, if there's a security incident on a laptop or against a server or a specific device, that gets reported back to a management system that can do correlation, that can do detection of attacks across multiple devices, because chances are if there's an incident in one location against one device, that same attack is going to be occurring across multiple devices. And if you know about it, then your security professionals can take action to mitigate those attacks. And the same thing is true in the IoT world. And if you think about an IoT device, if you take a simple case of an IoT gateway device that's communicating to a cloud system on one hand and to a network of sensors on the other hand, that device may have a web interface that allows users to log into it, to be able to do some configuration, to manage the device and the network, and to run reports and get some information on what's happening. That web-based login probably has a username and password on it. And most IoT devices are very simple in how they handle authentication. They receive a login request, they'll check the username and password or whatever credentials are provided. If the credentials are valid, they allow the login. If it's not, they just drop it and go on to process the next request. Where most IoT devices might see, 10 login attempts a day or 20 or 30 login attempts a day, if you have a cyber attack, some sort of a dictionary attack, say, against the device, suddenly you might be seeing 1,000 attempts an hour or more. The IoT device just receives the request, checks the credentials, and allows or blocks the request and goes on to the next request. It isn't smart enough to recognize that it's getting a flood of attacks, indicating that it's being probed, it's under attack. And again, this could happen over a telnet interface, a web interface, whatever interface the device has. But being able to detect and report that sort of anomalous behavior, as simple as that example is really important in ensuring the security of the overall network. So that integration with security management systems, again, an important piece that most IoT solutions just haven't caught up to the IT world in terms of their implementation yet. So one other thing that's really important to understand, right, if you're building security into your device, is to understand what sorts of vulnerabilities your device might have, what sorts of vulnerabilities hackers will take advantage of as they try to probe your device. And I present the list of vulnerabilities or the categories of vulnerabilities as an inverse pyramid here, because the ones at the top are ones that are most common, are most commonly exploited. They're the easiest to exploit. They're also the easiest to fix in most cases. Whereas the ones at the bottom are more obscure, they're harder to find, but also harder to fix. And typically, at least hopefully, fewer in number. So if we start, the first type of vulnerability we have to worry about is just lack of security controls. If you have an old device that has Modbus TCP on it or other legacy protocols, and oftentimes those protocols and systems are designed to be utilized in a world before we had the level of threat we have now. And there's just no authentication on it. If you can find the device, connect to the device, and talk to it, you can control the device. And there are things like Shodan, which is a search engine, It allows you to go out and do searches and discover these types of devices. So hackers have ways to find these devices and take over them. So that's the first thing that we see. The second is where we have security controls implemented, but there's loopholes. They have a hard-coded or default password that's easily discovered or included in the user documentation that hackers can find online, or they have backdoors in the device. And backdoors may seem like a good idea because they give your support team a way to remotely access the device to do debugging and user support. But those backdoors, if you can get into it in a fairly generic way, hackers are going to find that and find a way to exploit that. And we've seen examples where teams build in what they think is a very clever backdoor with some very obscure method of authenticating to allow them in. But hackers are just really, really good at finding those things. They've got automated tools to take the firmware for the device, reverse engineer the firmware, find those places where the device is doing authentication, and check for these sorts of things. And there's been published reports of people finding these and then attacks built to exploit them. Then the next category of problems is exploitable security controls. So here you've built in a security control, but it just isn't as strong as it needs to be. So for example, we may have a system where it's doing strong encryption, but in setting up the channel for encryption, it sends an encryption key or password in the clear, or the encryption just isn't strong enough to manage or to withstand modern attacks. And then finally, we have exploitable bugs, hardware or software bugs that attackers can utilize to take over the system. This can be anything from a buffer overflow attack to an issue in implementing a communication stack where it runs out of resources and allows attackers to take over control or to insert data into the device. So one of the questions that always comes up is, is this really a problem, right? Are there really people attacking IoT devices and sensor networks? And the reality is yes. And a few of the examples that I've seen are there was a well-publicized attack where hackers were able to break into the IT system in a casino, but they did so through a thermometer in a fish tank. So here you have an IoT, excuse me, an IoT sensor device that had a vulnerability that was exploited. We've seen other attacks. Excuse me, other attacks against implantable defibrillators and similar devices. We've seen smart light bulbs that have been hacked. And in some cases, once those devices were hacked, they were used as an attacking point to launch attacks further into the network. So the light bulb became the initial entry point for an attack against the IT network itself. And another example is if we look in the Zigbee world, there's multiple examples of security vulnerabilities in Zigbee-based devices that hackers have been able to exploit. So as we look at the problem and how we go forward, one of the things that we're seeing is a set of new regulations for security in the IoT world. And these apply broadly across IoT devices, including IoT sensor networks. So the state of California has passed a law requiring authentication methods in IoT devices, essentially making it illegal to sell devices that have a hard-coded or default password. And this is really important because that's how some of the high-profile botnets like the Mirai botnet have proliferated. The federal government has a proposed act. The UK has some proposed security guidance as well. And NIST has also published its own security guidance for IoT devices. So what all this means is that cybersecurity in the IoT world is no longer just a nice to have. We've seen significant security breaches. We know these devices are being attacked. And legislation is requiring us to build security into our devices. Now, this is a topic we can no longer ignore, but really need to begin addressing. So if we look now at security solutions for IoT devices, there's a number of elements or components to the security solution. As Matt said, I actually work for a company that is a certificate authority. So a large portion of what our company's business is issuing digital certificates for a wide range of use cases so that you can identify devices. In many cases, this is identifying a web server, but in the IoT world, this is just as important. When you put an IoT device on a network, you need to know that it's an authentic device. When that IoT device, be it a sensor, a gateway, other IoT device, attempts to communicate to other IoT devices in the network, you need to be able to verify that you're talking to who you think you are. So the first part of security in the IoT device world is ensuring the identity of devices. The other part of IoT security then is device integrity. So how do you ensure the firmware on the device is what it's supposed to be? How do you ensure that no one has tampered with the device, no one has stolen data from the device? These are all issues of device integrity. And some of the things that play into that are integration with hardware secure elements such as TPMs or other IoT specific hardware secure elements, implementing things like secure boot, embedded firewalls, as well as security protocols, TLS, DTLS, and so on. So broadly speaking, these are the two pieces or halves of the security problem in the IoT world. So if we look first at the identity piece and we think about that, the way identity evolved in the IT world is we started out with static credentials, a username and password. And from there it evolved to implementing multi-factor authentication because people stole passwords, they reused passwords, it just wasn't strong enough. So next came multi-factor authentication. Then for many devices, especially in corporate environments, we started using managed identities. But in the IoT device world, we're talking about headless devices. There's no keyboard and mouse, there's no human who's sitting there connecting to the device. We're not authenticating a human to the device, we're allowing the device to identify itself with another device. And in that case, managed identities often won't work, multi-factor authentication won't work. So we have this huge proliferation of static credentials. And this is true across types of IoT devices. So either, in many cases, it's a username and password, or some other hard-coded static credential, an SSH key that's hard-coded into the device. But whenever anything is hard-coded into the device, you can't manage it, you can't update it, it becomes a potential vulnerability. On the integrity side, some of the risks that we need to manage are ensuring the integrity of the firmware. We need to make sure that the firmware on the device hasn't been tampered with. Someone hasn't been able to change what code is running or insert malicious code into the device. We need to protect data as it's being transmitted between devices, encrypting data before it's sent across a network. And then we need to ensure that wherever the data is stored, on a gateway, on a sensor, even in the cloud, that it's protected, that that data cannot be manipulated by someone or stolen by someone. So these are some of the key elements of integrity that we need to be concerned with. So when we look at how we implement these various components, one of the security fundamentals for an IoT device is ensuring that you can authenticate the code on the device. So when the device first comes out of boot, it can check and make sure that it's running firmware that's from the OEM that hasn't been tampered with. And that's done through a process called secure boot. And again, just ensuring that the code hasn't been tampered with. And there's really two parts to the process. The first is when the manufacturer releases the code, it does a signing process where it creates a digital signature of the software, of the firmware that's stored on the device, and provides the device the information to allow it to do validation. So the device, when it first boots up, it uses the public key corresponding to the private key that signed the code to validate the software and ensure that it hasn't been tampered with. So this is one of those capabilities that's become commonplace in IT-based systems that needs to be broadly implemented in IoT devices. One of the advantages of having the ability to do code signing is it also enables secure firmware updates. So you can utilize that same process to validate new firmware when it's sent to the device to be updated. One of the other components that is ubiquitous in desktop machines and gateway type devices in the IT world, in laptops and servers, is a firewall running on the device. And in the embedded world, we need the same sort of solutions. We need to have a firewall on the device itself, protecting it from being attacked. And in this case, again, it's a specialized solution designed to run on the device itself that's easily portable to multiple devices to provide that protection. And again, it's not a general purpose firewall you'd see in the IT world, but something that can run on an IoT device to do filtering of packets coming into the device to ensure that they meet pre-configured set of rules, to block attackers, ensure that the people talking to the device are the authorized users. And again, I know this is a point I continue to make as I talk to people, but being able to manage this is an important part of that. And an embedded firewall SDK provides the ability to integrate with management systems and provide that management capability. So as we look at an embedded firewall, again, this is something that the Sectigo provides an SDK for that provides some easily configurable capability to do just basic filtering of Ethernet protocols or Ethernet traffic, IP, UDP traffic, and so on, as well as some specific deep packet inspection for some common protocols. And again, it's something that's a very small footprint capability that's easily ported to be used on any IoT device. So one of the other considerations in building security into an IoT device is understanding how to protect private keys. So if you're going to encrypt data on the device, if you're going to support secure communication through a protocol like DTLS, TLS, really any communication protocol, you have to have keys that are performing that encryption, and those keys must not be easily discovered, or hackers can find them and defeat the protocol. Right, keeping the keys protected is a critical component. And in the IoT world, there's really several different ways that this can be done. One is through use of a hardware secure element. So this could be a TPM if you're building an IoT gateway device, or other hardware secure elements that are built specifically for IoT use cases. The secure elements, TPM is a relatively expensive chip for a low-end IoT device. TPMs have become ubiquitous on Windows laptops and devices like that, but it's a little too expensive for some lower-end IoT devices. So there are specialized, lower-cost hardware secure elements for the IoT. But in either case, it's a physically separate chip where the keys can be stored. The keys can actually be generated on the chip, so they never have to leave the chip. And crypto operations can actually be passed to this separate chip. And this provides a very high level of protection. If a hacker is able to install malicious code on the device, they still can't get access to these private keys. If they steal the device and try to tear it down in their lab, they still can't get access to the keys because they're stored in this physically separate crypto chip that's highly protected. The next option is to implement a trusted execution environment like Trust Zone. And this is a little bit different because it's a single chip solution. So with this, what you actually have is a single physical execution area, but you have hardware support to isolate the execution area into a secure or protected world and a normal world. And this allows the secure world to perform crypto operations, to generate keys, and you only run a small subset of the code in that world that's been highly vetted, that is trusted, and then other operations and other code runs in the other portion that can't access that directly. So runs in the normal world or the insecure world. The final option is to implement a software-based security solution for key storage. This doesn't provide the same level of protection as a hardware-based solution, but it does provide some options for legacy devices or other low-cost devices that just don't have that hardware support. When we look at pulling all this together, both the identity piece and the integrity piece, the workflow and the process is important to understand. So the first part of it is to be able to issue certificates. So each device has to have that digital identity, that certificate that allows it to identify itself and to perform the transactions that it needs to perform in a secure way. And again, the issuance of the certificate starts with the management platform that can issue those certificates and then provides a mechanism to issue those certificates or provision those certificates onto the device. And that can be done during manufacturing of the device or when the device is first enrolled on a network and first provisioned and used on a network. And that can be done through standard protocols like EST and SCEP or through a REST API. And then at the same time, all those device integrity pieces must be built into the device itself, the secure boot facility, the data at rest, the data in motion, encryption capabilities, and the firewall. And then finally, when the device is operating, you need to be able to continue to ensure the security, right? So the first piece is provisioning and issuing certificates, programming them into the device, programming the security elements into the device. And then when the device is running, utilizing TLS for encrypting data in transit, for authenticating to the cloud or other devices that it's talking to, renewing certificates if they expire, revoking certificates if they if they're stolen or lost, and updating firmware over the air. So there's really a lot of components that fit into the full solution. So how do we apply this to a sensor network? One of the challenges is sensors are very small footprint, very low resource. So the first thing we want to do is wherever possible, leverage the gateway. We can build many of the security capabilities into the gateway, offload some of the heavy lifting into the gateway itself, and ensure that the gateway is very, very secure. We also need to have some method of ensuring the authenticity of sensors. And this fits into what the IT world is really pushing these days of the zero trust model, which means that you don't trust anything by default. Everything has to prove who it is before you trust it. And as we move into the IoT world, that zero trust model is another critical component of our overall security architecture or philosophy. We need to ensure data is encrypted, and there are scalable encryption algorithms available for small footprint devices. So we may choose to implement a different encryption method between a sensor node and the gateway versus what's implemented between the gateway and the cloud. And then again, understanding the security risks and how your device can be attacked so that you can implement a solution that's important for your environment. And then finally, let a partner help you. Right? There are many things that go into building security. It's an expensive proposition to build security into your device, and probably not something you want to do from scratch yourself. So just as a side note, if you found this interesting, Sectigo does have a podcast that a couple of our employees do called Root Causes that you can find that talk about a wide variety of security topics.
Thanks, Alan. That was a great presentation. Now we do have some questions from the viewers. We have a three-part question that's all three parts are related. The first part of the question is, do you find that with the advent of the Internet of Things and the mass proliferation of trillions of sensors, that malicious attacks are more prevalent, meaning attacks that are intended to do some damage to a system versus theft of data or theft of resources type of attacks? The second part is there one of those type of attacks more difficult to detect and defend against? And the third part is there a way to defend against both equally?
Yeah, so the first question or part of it was, are we seeing a difference between malicious attacks and just kind of white hat attacks? Can you repeat that part?
A malicious attack, meaning one that's intended to do damage to an external system, as opposed to just getting in to steal some data and maybe identity theft or hack into financial institution to steal money?
Yeah, so I think both are actually continuing to increase. With the Internet of Things, we're now seeing a set of devices that are controlling, physical operations. And so the ability to have an attack that's causing physical damage, is a new phenomenon that we didn't see, in the IT world. So those are definitely growing in a way that we hadn't seen previously. In terms of, but we have seen a number of attacks that people have used IoT devices as a gateway or a jumping off point to attack IT networks. So, so both of those are still occurring or are growing. The other thing that we've seen that's unique to the IoT, I mean, maybe not unique to the IoT, but is occurring on a new scale because of the number of IoT devices, is using IoT devices as a member of a botnet for a large scale DDoS attack. So really across the board, there's been a growth in the number of attacks and the types of attacks.
Well, the other part of the question is there is one type of attack, malicious versus data theft, is one a little bit more difficult to detect, meaning that if they were attacking for a malicious reason for destroying something, it might operate faster and avoid detection as opposed to somebody who may be in there hacking and stealing data over a period of time, which I guess I assume is easier to find.
Well, I think actually the attacks where they are stealing data are probably harder to find because while there may be an electronic trail of evidence, there isn't the physical evidence. If someone is able to hack in, well, there was an attack around Christmas time in, I want to say 2016, but it may have been earlier than that, in Germany against a steel mill where hackers got into the control network. And as a result of the attack, they actually had to do an emergency shutdown of a blast furnace in a steel mill. And it destroyed the blast furnace. So, so in that case, it was obvious what had happened. If people are exfiltrating data through an IoT device, or an attack like that, it can be much more difficult to detect that sort of behavior.
Mm-hmm. Okay, great. I got a couple more questions here right now. Here's one. It says, can I just build security into the gateway that sensors communicate with and not worry about adding security to the sensor itself?
So I think if I was, as we work with companies that are building these types of networks and devices, our approach is really to start with building security into the gateway itself. That's really a critical piece of it. That's the piece that's facing the internet. It's the piece that's most likely to be attacked. So it's a great starting point, but I really don't think that that's sufficient. It is important to ensure that at least basic levels of security are built into the sensors themselves as well.
Well, what type of security would be built into a sensor? Because it appears that they seem to be very application specific, like pressure, temperature, whatever. What would be some of your insights on that?
Yeah, and that will vary quite a bit depending upon how you're defining a sensor. If the sensor is, some of the very, very low cost sensors that are truly just pure sensors that are just collecting, sensing some information, taking that data and sending it to a gateway. Well, the thing that you need to do there is probably ensure at a minimum that you can authenticate the sensor so that you know who you're talking to, so that the gateway knows that it's talking to the right device. So that's kind of the minimum fundamental. Ensuring some level of encryption between the sensor and the gateway is another piece that's important. But also having some method of ensuring that you've got at least an ability to update the firmware securely and validate the firmware through secure boot on the sensor are also things that I would look at. If you're building a more complex device that's a sensor that's also controlling some operation and has a little bit more capability, then ensuring that you've got hardware secure element built in for secure key storage, probably a more robust protection against attacks, and things like the firewall component start to become important as well.
Mhm. Okay, great. We got a question from, I'll just use the first name, Joe. He wants to know, do you think that the present regulatory standards for security adequately cover sensors and IoT devices?
That's actually a really interesting question. I've been having some conversations with a number of folks on this topic lately. And I think that what we're seeing is, a good first step towards requiring security in IoT devices, but I really don't think it's sufficient. Um, Most of if you look at the California regulation, really what they're saying is you can't use hard-coded username and passwords or default username and passwords. And it doesn't go a long ways beyond that. Um, Things like the NIST guidance are more comprehensive, and take it, another significantly, move the ball significantly further down the field. But then there are other things like, ensuring vulnerability reporting, is done broadly, security testing standards. One of the challenges if somebody's trying to buy a device is understanding how secure the device is. So Underwriter Labs has started a program to be able to do a security authentication or security rating on a device. So the consumers can say, okay, here's 10 devices I can choose from, and can start to make decisions based on how secure the device is. So again, I think what we have seen is a good start, but I really think that those other elements are important, and we do have a ways to go to achieve where we need to be.
Okay, great. We have another question here. This is from a gentleman. His name is Mike. The sensors I'm working with, he said, the sensors I am working on have very little memory available for implementing security features. What can I realistically implement on my sensor to improve the security for the sensor?
So there's two ways to look at this. The first probably isn't going to be very helpful on the specific project, but one of the questions is, how much do we invest in building security into our devices? And many sensors do utilize very, very low cost platforms that leave very little headroom for implementing security. And so, I think there are all kinds of arguments that if you spend too much on the platform, your device becomes prohibitively expensive, or there's issues with battery life or other things. But I do think overall we need to select platforms that have greater capability to build security into them. And that gets back into the regulation questions and some of that, because an individual company really can't. It's tough to be the market leader in adding security, because you're going to have a little bit more expensive product, and that's tough on a competitive front. And some of that's where the security requirements and security regulations come into play. But specifically, if you do have a product that you're building and have limited resources on what you can build, again, some of that is ensuring you've got very strong security in the gateway, so that at least that piece is well protected, and then ensuring you've got some level of authentication with your device. You may not be able to support a PKI certificate in every IoT sensor device, but ensuring that you have some method of doing authentication to validate that you're talking to an authentic device, having some level of secure boot so that you can validate that the code is authentic, are things that I would start with.
Okay,
I
great.
guess,
Well,
yeah, the other thing I would say, just to expand on that too, is,
sure.
there are, many of the solutions can be implemented in a very scalable way. You may choose to use some lighter weight crypto algorithms, for example, or, when you're talking about secure boot, there are a lot of features that can be included in secure boot on an IoT gateway. And then when you implement secure boot on the sensor device, you may implement a much more scaled back solution to allow it to fit within the headroom you have.
Okay, great. Well, that's all we have time for today. I want to thank Alan Grau and Sectigo for spending time with us today and for a productive and insightful presentation. And I want to thank all the attendees today. Remember, this webinar was recorded and will be available on the Sensors Daily website shortly. And don't forget to sign on for upcoming webinars from OmniVision and Wiser Systems. Have a great day.